Hello class, we are going to go over 3 and 5e. I talked about it in class. I was going to show a video on 3 and 5e. So this number 3 is the topic of expected value. We are wondering what can we do here to make this game fair. So here is a dart game at the SB Fiestas. Assume that every single time you throw a dart, you will hit this board, okay? Also, you can assume that the dart will be randomly. It will be random, so every single time it's a random shot. And the vendor of this game wants to be fair. That means he doesn't want to win or lose any money, so he actually just wants to get $0, okay? He also wants to charge $2 every single time. So when I'm saying fair, he charges $2, then he's gonna lose it too. So he wants, and overall he just wants to make no money, lose no money, gain no money. Okay, if the vendor charge is $2 per throw, and he wants the game to be fair, meaning at the end he wants to be $0, what amount should go on this bottom? So we don't know what this amount is. Okay, so what amount should this be to make sure that, and in the end, all of this will be $0. So let's just put that right now. In the end, everything is $0. Okay, so this here is going to be a square. That means all of this is going to be evenly sectioned. If we look at this one first, you can see this section here. This whole section is half, and this is half of a half. Half of a half is 1/4. So this right here has a 1/4 probability. But he wants to be fair. He charges $2 to play. So if he charges $2 to play and you get this, you won't win $5. You technically put $2 in first, so you only win your $3 because you started off with $2 and you won $3 and you have a total of $5 now. But technically, every single time you play, if you land here, every time you just win $3. Okay, here, this right here is also, you can see that this is half of the whole thing and it's half of a half. So since you know it's a half of a half, this is also 1/4. And this is, you lose another $8. That means you put in $2 and you lose another $2, or sorry, $8. So you lose 8 and 2. That means you will lose a total of $10. Okay, now look here. This is half and this is half of the half. So this is 1/4 and this is 1/4, half of 1/4. Half of 1/4 is 1/8. So each of these is 1/8. Okay, so here, this is 1/8. You win $50, but remember, you put $2 in, so you actually only win $48 if you win this, because you had the $2 and you had 48 more now. So this is a 1/8, and you win $48 because you put in that $2. Here, same thing. You put in $2 first, and you lose another 40, so that's losing $42. So that's 1/8, and this time you're losing $42. Right, because you put in the $2 first. And here, this is X amount. He wants to be fair. So you can see that you're winning some, and then you're losing money. And he wants to balance this amount, right? He wants this whole entire dart to eventually be $0 if everyone keeps on throwing. So we want this to make sure that this amount adds up to $0, and you want this to be a number, and you know that whatever amount you gain or lose here, you start off with $2. So I subtracted 2 from each of these, so I have to subtract 2 from this as well. And this is a 1/4 because it's 1/4 of the whole entire thing. So this is 1/4 x minus $2. So that's an amount. So here we have a lot of calculations we have to do. So here we want this all to be equal to 0, and we need to find this x here. Okay, 1/4 of $3, if you put this in here, that's 3 out of 4. If you multiply that, 3 out of 4 means 75 cents. Here, 1/4 of 10, that is 10 out of 4. And if you divide that, that goes into it twice. The 2, 0, 5, so it's 2.5, and it's a negative 2.5 because it's a negative $10. Okay, 1/8 of 48, well, you just cross multiply here, that's 6. That's $6. Here, this is 42, so you have to go ahead and divide that, so it's 42 over 8, so, that's 42 over 8 divide that, that goes not 6 times, it would be less, so that's 5 times 40. 2 left over. 8 goes into 20 2 times, 16, 4, 0, 45. So 5.25, and this was a negative, so that's a negative $5.25. And then we have here 1/4 times x minus 2. This is a distributive property problem. You can see you have to distribute each part. 1/4 x minus, right here, that is going to be 1/4 times 2. That's 1 over 2, that's 0.5. That's 50 cents right here. And it's all equal to 0. Okay, so here, you can add all this up. I'm going to add all the positives together. So that's $6.75. And then all the negatives is this one, and this one. I'll add all the negative dollars up. That's $2.50. That's $5.25, and that's 50 cents. Add up all the negatives. That's 10, 12, 8. So that's all the negatives. So it's negative 8.25. That's dollars still. Plus 1/4 x equals 0. Okay, so I need to subtract these two. These are different signs. That means I need to subtract them and keep the bigger one, right? So it's going to be a negative answer. So I have to subtract them. 0, I have to borrow. It's 1. So this is negative. This right here is negative $1.50 plus 1/4 x equals 0. I add 150 to both sides. I have 1/4 equals 150. And 1/4 means divided by 4, so we have to multiply by 4. So x equals, what's 150 times 4, $1, that's 0. 24 plus 2, 6. That is $6 for it to be, to be fair completely. So that's what you're looking for here. That was the answer. Okay, now let's go to the back. Let's do 5E. Okay, so to find the MAD, the mean absolute deviation, you need to know what the mean is. So before, we need to know what the mean is. We calculated with the class, and I believe a lot of you got this correct, but if you find the mean here, you should get 3.5. That means you added 1 plus 1 plus 1, which is 3, 1.5, 6. This is 3, that's 9, that's 7, that's 4, 5, 5.5, 6, and 21. You added all those up, and then you divided by, you add all of it up, and you should have gotten 70, and then you divide by 20, and you get 3.5. Okay. So that was just a quick overview if you didn't get that right, but here is the mean absolute deviation. The way you find the mean absolute deviation is you break down the mean here. Okay, the mean, you want to figure out all the numbers that deviate and how much they deviate from this 3.5. So here's my 3.5, I'll center it right there. And I have all this data that in the sample that I need to figure out how much they deviate. So here's 3.5. How many numbers deviate from 3.5? That's 3.5, that's 0. That means they deviate 0 times. This is 3. How much do the number 3 deviate from 3.5? That means, what's the difference? This is different by 0.5, each of them. 0.5, 0.5, 0.5. So 0.5, 0.5, 0.5. Okay, my next number is 2.5. There's none, so I'm not going to even leave it in. So I'm just going to go right over to 2. 2. Okay, how far does 2 from 3.5? Well, 1.5, because you subtract. So 1, 2, 3, 4. So they deviate by 1.5, 1.5, 1.5, 1.5. Okay, now I have 1.5. How far away is 1.5 from 3.5? Oh, 2. So they deviate from 2 by 2. So that's that. And then here, last one is a 1. How far away is 1 from 3.5? That's 2.5, and that's 3 of them. 2.5, 2.5, 2.5. Okay, 4 now. Now let's go to the right side. So we found all the deviations on this side. We need to find all the deviation on this side now. So we have 4. 4 deviates from 3.5 by 0.5. There's the next number, 5. 5 deviates from 3.5 by 1.5. There's only one of them. We have the next one, 5.5. 5.5 and 3.5, they deviate from each other by 2. 6, you can kind of see the pattern now. This is another 0.5. And then after 6 is 7. And there's 3 of these, so there's 3 numbers here. So 7 subtracted by 3.5, oh, that's just 3.5. There's 3 of them, 3.5, 3.5, 3.5. Okay, so this is pretty much your work, right? This is your data of all the numbers that deviate from it. There should be 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there's 20 numbers here. We found out how much of those 20 numbers are away from the mean, right? And then now what we're going to do is we're going to find the mean of it. That means we're going to find the average deviation. That's what this means. We used to make it, I used to put the side all negative, but we all know that it has to be the absolute anyways. That means we all need to make it positive. So I made all of the numbers positive. So let's find the average amount they all deviate. Well, here's all the numbers. I can write it all out, or I can just, well, I know it's all going to be divided by 20 because there's 20 of them. I'm trying to find the average. So this right here is, I'm going to do a little shortcut of adding. So that's 7.5 here. This is 2. 1.5, 1.5 is 3, plus another 3 is 6. This is another 1.5. This is 0. This is a total of 0.5. Actually, I'll put these together. That's a total of 2. This is a total of 4.5. And this is 7. Plus another 3.5 is 10.5. So add all these numbers up. Let's make this a little bit longer. So I have 7.5 plus 2 plus 6 plus 1.5 plus 0 plus 2 plus 4.5 and 10.5. Okay, so here I have these two numbers. That's 9.5, 7.5. Let's add all of these up. So that's 10.5, 4.5, and 2. Oh, sorry, plus 2. Whoops. Here, that's 17 over 20. Yeah, these up. That's going to be 17 plus 17 over 20. That's 34 over 20. And let's divide that. 20 goes into 34 one time. That's 14. And that goes into it 7 times. So your MAD is 1.7. That means the amount of numbers, the way it spreads from each of these, a lot of the numbers overall, the whole entire data, that means they deviate on average 1.7. That means they're $1.70 away from each other from the mean on average. If this number was really small, like 0.2, that means this right here is all groceries. This is all groceries, so this is all the prices of grocery. So they're all, like, if it was 20 cents, they're all 20 cents away from each other. So if you're at, like, for example, the 99-cent store, the MAD would be 0 because they're all 99 cents. But if it's a special 99-cent store where they have a lot of different prices, then this MAD will get a lot bigger because there's some things that are much more expensive than 99 cents. So this just tells you how far away everything is from this mean. Okay? All right, thank you for watching this video. I hope you have a good day. Bye.